Hi everyone, in 2.2 we're going to use our next method for integrating messier functions. So basically here we want to work on reversing the product rule, whereas with U substitution we were working on reversing the chain rule. And we won't really work on reversing the quotient rule, the idea being if you have a quotient you could always rewrite it as a product, so just working on the product rule should get us something. Okay, so let's start. This is a preview activity, so please pause, try and work through. If you get stuck, come back in, check it out. So we're going to start by taking a derivative using the product rule. So when I look at this, the big operation is that multiplication right there. So I'm going to say I get the second times the derivative of the first. Derivative of x is 1. And then I have a plus the first. The derivative of the second is just another e to the x. So there's my answer. Based on this, we are supposed to figure out the antiderivative of x e to the x plus e to the x. So if the derivative of x e to the x is e to the x plus x e to the x, then the antiderivative of e to the x plus x e to the x is x e to the x. So that sounded really messy, but hopefully you can see the back and forth there. So we're basically asked to integrate the thing that we just found, and we know that that thing is the derivative of x e to the x. And there could be a plus c in the mix there. Let me think if I think that's going to be tricky. Nope, I think we'll go ahead and throw it in. Okay, and here's the part that might not immediately have been obvious what to do. Down below, I'm asked to then find the integral of just x e to the x. So it's really just that part. So what I want to do is I want to take the statement that I just wrote down really seriously and say, okay, well, if I know that the integral of x e to the x plus e to the x dx is equal to x e to the x plus c, I can start using some properties. I can split up this integral. And one of those is actually really easy. I know that the antiderivative of e to the x is e to the x. That's not an equals. I said is as I was writing. And we don't really need to throw another plus c in the mix, because really what we would have then is a c1 on one side and a c2 on the other side, and when we move them over and say, okay, well now we have c2 minus c1, or vice versa, it's not very exciting, because if you take something that represents any real number minus something else that could represent any real number, really the result is just going to be any real number. You can still get absolutely anything from that. So all I really need to do here is subtract, and I can say that the integral of x e to the x is equal to x e to the x minus e to the x plus c. So this is just subtracting e to the x from both sides and solving for this integral. And this trick of solving for the integral is something that we are going to see in other ways as well, so kind of pay attention to that. It'll crop back up actually later in this section as a trick for solving some interesting things. So this is the idea behind the product rule. If you have something that's the derivative of a product rule function, then there should be that first times the derivative of the second, and that second times the derivative of the first. And sometimes one of those is really easy to integrate, and that would allow you to solve for the other one. So this is preview. This is the idea of what we're going to do, and then we'll actually write it down a little more officially in, I think, the next one. Thanks for watching.